Okay guys, in this video we're going to be talking about differentiation. We're going to do the basic, the simple, the complex question about this topic. Let's first start with what we mean by differentiation. That of differentiating y with respect to x, the coefficient of y with respect to x. And we read the formula go like this: differentiation to be the y, the x is equal to n x raised to power n minus 1, in which our n is equal to 1, 2, 3, 4, 5, 1 over 2, 1 over 5, any number and so on. So if we are given a question that let differentiate 2x squared, so we are just going to say n and be this n. So this one will multiply this. We have 4x raised to power our n 2 minus of 1. That is going to be 4x raised to power 1. Just like 4x. So we have like 3x raised to power 3. We have 3 times 3 x raised to power what? 3 minus of 1, which is what? 9x raised to power of 2. So we have something like 1 over 4 raised to power x raised to power 3. We are going to have 3, that's what 3 times 1 over 4 raised to power x raised to power 3 minus of 1.
Okay, minus 1 is constant.
Yes, that's a constant from the formula. So we have 3 all over 4 x raised to power 3 minus 1, we have 2. So this is the same thing as what? 3x squared all over 4. These are just the basis of differentiation. Now let's look at some question from the textbook. We are asked to differentiate a. We have 7x squared. B. We have 5x cubed. C. We have 2x cubed minus 3x squared. And D, we have 6 plus 5x minus x squared. Okay, this is the question. These are the question. So solution. Now let me tell you some things. Differentiation of any constant number, that is a whole number like 1, 2, 3, 4, 5 and so on. The differentiation, the divide the x will be equal to 0. That's the differentiation of any constant. You divide the x will always give you 0. So let's start with the first question. A, we have 7x squared. So going by our formula, divide the x is equal to what? N x raised to power n minus 1. So we have 2 times 7 x raised to power 2 minus of 1 is what? 14x raised to power 3. That's the answer for the first question.
2 minus 1.
For second, 2 minus 1, so we have 1. This is the answer what? 14x. So second question, we have B. So we have 5 raised to power x, 5x raised to power what? 3. So we have 3 times 5 what? X raised to power what? 2, 3 minus of 1. 3 minus 1 is what? 2. So 3 times 5 we have 15 x raised to power 2. That's the answer for the second question. For the third question, we have 2x cubed minus 3x squared. So we are going to do this one separate, this one to separate. So the relation of this will give us what? 3 times 2 x raised to power what? 3 minus of 1 minus, so will give us what? 2 times 3 x raised to power what? 2 minus of 1. So we have 6x 3 minus 1 we have what? 2
2.
minus 2 times 3 will give us what? 6 x. 2 minus 1 will give us what? 1. So the answer is what? 6x square minus 6x. So this is the answer for this. And for the last question, for me I can just say 6 into bracket what? X square minus of x. It is the same thing. So we have, and for the last question we have D. We have 6 plus 5x minus x squared. So I divide the x for this. For any constant, divide the x is what? 0 plus. Now for this we have 5. You know we have an invisible 1 here. Yes. So for you to differentiate, this one will be what? 1 times 5, which is going to give us 5 x, and then 1 minus 1 minus what? X squared. So 0 means nothing. So 1 times 5 we have 5. X to the power what? 0.
Invisible one that will be at the back of x.
That's 1 times 5.
X square. X square. X square. Invisible one.
Okay, for our x square, we have this. This one, for differentiation of x square, we are going to have 2 times 1 x to the power what? 2 minus of 1. So we have 2x this power what? 1. So 5 x to the power 0 is what? 1. 5 times 1 minus 2x. This is going to give us what? 5 minus 2x. Hope it is understood.
Yes.
So if simple thing, the differentiation of any constant will give us 0, and the differentiation of 5x, 6x, 7x, anything that has x this power 1, the differentiation is the constant, is their coefficient. So if you have the differentiation of 2x, you divide the x, be what? 2. The differentiation of 3x, divide the x, is going to be 3. Now let's move to more complex question. We have
More complex.
Let's move to more complex question. Now there is a rule known as chain rule. Now chain rule. This is when we have our differential equation to be raised to power maybe like 5, 6, 4 of higher powers. For example, we have something like differentiate 2x minus 5 raised to power 4. So for me to do equation like this, instead of start splitting everything to be 2x minus 5, 2x minus 5, 2x minus 5, and 2x minus 5, and start opening the bracket. So they come up with a formula known as chain, with a rule known as chain rule. So right here, the chain rule now states that we have our divide the x, our divide the x will be equal to the u the x multiplied by our the t the x. That's our formula for our divide the x. So for our chain rule. Now let's apply the rule. Solution. We have 2x minus 5 x raised to power 4. So you can say let u be equal to 2x minus 5. That is what is inside the bracket. We let u be equal to 2x minus 5. Then our question will now be what? U raised to power 4. Since the whole this is now u. So going by our formula, divide the x so we have divide the x is equal to what? The u the x multiplied by what?
The t
the x. So right here, or you can also say this the t, so that there will not be confusion. Let's say it's y, divide the x, also divide the x. So we have u raised to power, this simply means that you are going to differentiate this u raised to power 4, then multiply it by differentiation of this 2x minus 5. That is the dy dx of u raised to power 4 multiplied by what? The dy dx of what? 2x minus 5 will give you the answer of this. Do you get it? We first said this our bracket u, let it be u. Then our question will go to change for what? U raised to power 4. When our u is ready, 2x minus 5, then 2x minus 5 is u, so between it we have u raised to power 4. Remember our formula, the y dx equals to the u dx times the y dx or the dx anyhow. So this means that what? The differentiation of this, our the u dx, that's the differentiation of this multiplied by the differentiation of this, our constant 2x minus of 5. So we have the y dx of u raised to power 4 multiplied by the y dx of 2x minus of 5. So the y dx of this, you know that our formula is what? We have our formula to be what? Nx n minus 1, right? So we have 4 times u raised to power what? 4 minus of 1 multiplied by what? The differentiation of 2x is what? 2. The differentiation of any constant is what? 0. So we have 4u raised to power 3 multiplied by 2. So 2 times 4 we have 8u raised to power of 3. But don't forget that our u is what? 2x minus 5. Now let's substitute it back. Let's substitute. So for u is equal to 2x minus 5 in the equation. So we have 8. Our u is what? 2x minus 5. That's 2x minus 5 x to the power of 3. So this is our final answer. Let me re-explain. We have 2x minus 5 raised to power 4. Let u, first say let u be equal to what? 2x minus 5. And what is inside this bracket? Then our u raised to power, that will be what? When u is already 2x minus 5, then we say this one to be what? U raised to power of 4. The y dx is equal to what? The dx multiplied by the y dx. Formula, the y dx is equal to what? The dx times the y dx. So this one might be the dx. I intentionally use the y dx so that there won't be confusion. That is y dx of this u raised to power 4 multiplied by the y dx of our substitute. U is equal to what? 2x minus 5. That's 2x minus 5. So going by our formula for dx, n x raised to power n minus 1. So the differentiation of u raised to power 4 is going to be what? 4u raised to power of 3 multiplied by the derivation of any constant or of 2x is what? 2, and of any constant is 0. So we have 2 times 4 to be 8 u raised to power of 3. Now from here, so for u is equal to 2x minus 5 in the equation. So we have 8. Our u is what? 2x minus 5. 2x minus 5, everything is power what? 3. So